Okay, so now to the back. We are going to take a look at number 10. So 10, 11, and 12, we're not going to do them all, but I just wanted to show you some with fractions, some with zeros and imaginary numbers, and just so you can see how everything would be written. Um, Notice that when I'm given my root, when I'm given my solution, its factor is always just going to be the opposite sign, right? So this, instead of being a negative 2, would be x plus 2. Even with a fraction, if I have a positive 2/3, this is just going to be an x minus 2/3. And then finally, if I have a positive 1, this is just going to be an x minus 1. Now, the nice thing about the Moyes method we learned is that when you have a denominator, you just bring that baby out in front. So what I could do is I could rewrite this as x plus 2 times 3x minus 2 times x minus 1. Now, what you're going to have to do is you'll have to go through and distribute all of these through. It doesn't matter where you start, but you'll distribute these through first, write your answer, and then you'll have to distribute whatever your answer was here to each of your two terms in the other set of parentheses. And so you'll have to take some time distributing. If you need help with that, we can go over that a little bit more in class. Now, taking a look at numbers 11 and 12, I wanted to take a look at the same thing, but just not spend a bunch of time going over it. So, for example, if I have a root of x equals 0, that means I have a factor of 0 just out in front. And then if I have x equals 3, this is x minus 3. And then notice how I have plus or minus 5. So I'm going to have x minus 5i and then x plus 5i. Now, one thing I do want to point out is that when you go and distribute this, what's going to happen is, so I'm not going to worry about distributing this over here, but x times x is going to give us x squared. X times a positive 5i would be plus 5ix. A negative 5i times x would be a negative 5ix. And then finally, a negative 5i times a positive 5i is a negative 25i squared. Now, if you remember, I squared technically equals negative 1. And so really what we could say is that we have this x squared plus 5ix minus 5ix minus this 25. Instead of times I squared, if I squared is negative 1, then it's times negative 1. And you might remember now, some of you were able to see this and you go, hey, once I see it's minus 25i squared, can't I just flip the sign? Isn't that all it does? And you're absolutely right. This minus 25i squared just becomes positive 25. But the reason it becomes positive 25 is because you have this negative 25 times a negative 1, which gives you that positive 25. When you do this right, you get a positive 5ix canceling out with a negative 5ix. So the only thing you have left over is the x squared plus this 25. Now, you would still have to take this in its own separate parentheses and distribute this to what you get after you take your x times your x minus 3, so that would be x squared minus 3x. And you would have to distribute that one more time, but just for sake of time, we're not going to do that right now. Finally, number 12, I'm going to take number 12 and move this up a little bit. I just want to write the problem out. So if we have a negative 1/3, then we could say this is x plus 1/3. And remember, with the fraction, you take the denominator and bring that out in front. So really, we're saying 3x plus 1. And then a positive 2i, this becomes x minus 2i. And then the negative 2i becomes x plus 2i. And so again, you would have to go through and distribute that all the way through, recognizing that when you distribute these two fractions with your i's, you're going to get an x squared plus 4. So if you want to quickly check that after you simplify and reduce, you should get an x squared plus 4 there. All right, now moving on to factoring. We're going to do some of these quicker than others, but here we have the Moyes method, and so I'm going to take that 3 and multiply it to the negative 2, and so we're going to undo that later. So we get x squared minus 5x minus 6. And then now this is just a normal problem. I need two numbers that multiply to get me that negative 6, that at the same time add to get me a negative 5. So it'd be a negative 6 and a positive 1. Again, order doesn't matter. Now this is where this 3 comes in, right? So if I multiply the 3 in the beginning, how I undo that is by dividing by 3. And so when I do that, I want to reduce if possible. So here I have x minus 2, and here I have x plus 1/3. That doesn't reduce. And so because it doesn't reduce and we're not solving, we're just factoring, we have to take that denominator and bring it out in front if there is one. So our final answer is x minus 2 times 3x plus 1. So that would be our final answer here. In 14, we have a difference of 2 squares. So separated by a minus sign and 2 perfect squares. If I set up my 2 sets of parentheses, it's going to be x plus something, x minus something. And how I find that something is by taking the square root of 49, which is 7. 7 times 7 is 49. So a positive times a negative gives me that negative 49. And then x times x gives me x squared. So difference of 2 squares. Now what about this? It's been a while, but sum and difference of cubes. So let's take a look at what that looks like. Sum and difference of cubes. So given that we have something that's like a to the third minus b to the third, what we're going to do is we're going to figure out, okay, what is a, what is b? We're going to subtract them or whatever that sign is. So a minus b. And then our other part of the formula, I might run out of room here, is we take the first term and we square it. So we have a squared plus ab plus b squared. And we used something called SOAP to deal with our signs. So remember, S was always going to be the same sign as our original. O was always going to be the opposite sign of that original. And our last term is always positive. Right? So same sign, opposite sign, always positive. And then how we figure out, okay, once I know A and B, seems like no big deal, but how do I find these other things? Well, you square the first term, multiply them together, square the last term. So once you get some practice, it's not terrible. Now remember, in your calculator, if you want to find the cube root of these numbers, if they're a little bit larger and unknown to you, what you can do is in your calculator hit math and option number 4. And when you do that, you would find out that, hey, this is just 6, meaning 6 times 6 times 6 3 times would give me 216. So our first term, our a, is 6x minus, because it's always going to be the same sign. What times what times what is 64? Well, that would be 4, so minus 4. Now, how do I find the first term? Well, I square it. I'm going to just take this first term and square it. So what is 6x times 6x? That's 36x squared. Now think about SOAP. We have our same sign and then opposite sign. And how would I find what comes after that? I multiply these two terms together. So multiply a 6x minus, multiply 6x to the 4. So 6x times 4 is 24x. So same sign, opposite sign, always positive, and then we're going to square our last term, which is 16. So you don't have to go any farther than this. We're just factoring or breaking it down in sum or difference of cubes. All right, finally, the last question. Even though there are multiple parts here, we're going to take a look at this one and do a lot of them, some in detail, some quickly. But let's take a look. So first, what is the y-intercept? It's always your constant, the number by itself. So we're going to, oh, I'm sorry, I forgot. Yeah, with this one, I messed this up. So go Tigers. So sorry if you already did it. What I want you to do is change a couple things. So this is going to be x to the 4th minus 13x squared plus 36. So yeah, that was my mistake. So sorry about that. So hey, if you already did the first one and you thought, wow, this is hard, you were correct. Let's take a look at the new one, and hopefully you have a good pencil, or you can just write this on another piece of paper. All right, so what is my y-intercept? Y-intercept is the number by itself, right? So that is our constant, so 36. So it's going to cross the x-axis, or the y-axis at 36. Well, notice we don't have a y-axis that goes up that high. Now, then letter B says factor to find all of the x-intercepts. So if I factor this, let's see, I know that x squared times x squared is going to get me x to the 4th. I need two numbers that multiply to a 36 but add to a negative 13. So that's going to be a negative 9 and a negative 4. So negative 9, negative 4. So negative 9 times negative 4 is positive 36. Negative 9 and negative 4 added together is a negative 13. Now notice that these can be factored again. This x squared minus 9, that's just difference of squares. So this can be x plus 3 and x minus 3. That's a 3. Just doesn't look like it. Here, x squared minus 4 could be x plus 2, x minus 2. And then so what I get is I get all of these x values. I get that x equals, remember it's always the opposite sign, so a negative 3, a positive 3, man, those 3's are rough, a negative 2, and a positive 2. So here are my 4 solutions. Now what does that mean? That means we're going to have points here at negative 3, at negative 2, positive 2, and positive 3. Okay, so we're going to use that here in a moment. And end behavior. Now, because this is an x to the 4th graph, we know it's going to look something like a W, right? So our end behavior is going to point up forever in both directions. So as I go to the left or to the right, it doesn't matter. We're going to go up continuously to positive infinity. So it's kind of that arrow notation. So we don't care about what's going on in the middle. For end behavior, we just care about the ends. All right, now it's talking about all the maxes and minimums. And so in your graphing calculator or in Desmos, if you went, you have one maximum. And it's not the absolute highest that you can go, so it's called a relative max. And this occurs actually on the y-axis. And this is where the graph changes direction. And this is at the point 0, 36. And the reason it's not the absolute highest is because of our arrows. Those are going to have the graph go way higher than this point right here, which is 0, 36. Well, then we have some absolute minimums. Those are absolute because they're the absolute lowest that we can go. So we have 2 absolute minimums, and they're just at the same point. And so using your graphing calculator or your Desmos, we have one at negative 2.5, 6.25. And then we have another at 2.5 positive, negative 6.25. And so what we're saying is that these are kind of halfway in between, and they're going down, and they're about right here. So it's going to be the minimum. So halfway between, going to be about right here. All right, so here's what this crazy graph looks like. It's this big W, like this. Now I kind of missed. But this graph's going to look something like this. Now, the graph on the test is going to be a little easier than what I just gave you. But the important point is, can you find all of this stuff using your calculator or factoring or knowledge of end behavior and y-intercepts? Okay, finally, so where is this function greater than or equal to 0? So where is this above our x-axis? And then where is it less than 0? Where is it below the x-axis? Just quickly, let's start with letter G first. And so where is it underneath 0? Not equal to, but underneath. So this first section and this second section here. So it's underneath all of the x values that give me a y value that's negative, underneath the graph, from negative 3 to negative 2. Union, so now this other section is going to be from positive 2 to positive 3. So remember, it's always lowest, highest. So that's where it's underneath the graph. Now, unfortunately, above the graph, we actually have 3 pieces. I have one piece right here, I have this big chunk right here, and this one piece here that goes on forever, right? So the arrows represent infinity. So we're going to have 3 sections. We're going to have from negative infinity all the way down to negative 3. Now, because it can equal 0, we're going to put negative 3 with a bracket. And then union, our second piece, is going to be from negative 2 all the way up and back down to positive 2. So brackets, because it can equal, so negative 2 to positive 2. I better fix that. Sorry. Negative 2 to positive 2. Finally, our third piece, so union again, and this is starting at -3, and it's going up forever to infinity. So we're going to say from, I think I said -3, I meant +3. So from +3 all the way to positive infinity. And remember, infinity is a parenthesis, so whether it's positive or negative infinity, we do not use brackets dealing with infinity because it's not a point that you can plot. It's a concept, an idea that goes on forever. So I know this was longer videos than normal and a little bit quick for a review session, but we will also review in class. So please make sure you ask some questions and circle some things that you're unsure about. And if you want to practice more problems similar, let me know and we will make it happen.